All right, here we are. We're back, and well, situating my windows off screen. Uh, yeah. So picking up where we left off last time. That is, we came to the place that we realized that in order for us to move on, and I've got a spot on my glasses. Oh well, I'll keep going. In order for us to continue our development, we've got to do better than just using raw pointers. I want to have, there's two things I want. Number one is I want to have reference counting. That way I can make copies but not have to copy the actual whatever is being pointed to. And why should I want something like that? Well, it's I know what I'm trying to say. The reason I want something like that is so that you can well, save memory resources, be a little bit more efficient. But and you get that with shared pointers, but we can't use shared pointers. Why? Because they're very slow. And I had written my own sort of wrapper class for this type of thing, and it was definitely faster than shared pointers, and it was almost as fast as using bare pointers themselves. So, in fact, I mean, it was neck and neck. I couldn't tell a difference. So I think that's a good thing. And then the second thing is that we want to use an object pool, a memory pool. The ability to be able to pool or minimize our number of allocations. And the problem with that is, well, quite frankly, I couldn't find one that existed that I liked. There's Boost evidently has one, but hasn't been maintained, and I've been going back and forth, and I've decided that's it. We're just going to write our own because well, why not? We write everything else ourselves. So, what is this going to look like? Might as well. We're just going to jump in. So I'm in my. Oh, I should switch my screen. There we go. I am in just the directory, and don't know why I click somewhere and evidently it turns on the scroll lock, and I had to hit Control Q to turn off the scroll lock, and I don't know what is causing that to happen. But anyway, all right. So in this particular case, yes. What am I doing? We need to create this file. Um, include slash, and what do I want to call it? I think I want to call it Singleton object pool or just an object pool. Uh, we'll just use object pool and know that in well no Singleton object pool just in case we ever need a non-Singleton object pool. Dot HPP. All right, this doesn't exist, but now, okay. If in def, all right, and then pound, and if, that should be good. Now, what is this going to be? First of all, it's going to be namespace Tang, and it's going to be a class. Now this, I'm already going to back up and say this is going to be templated. Why? Because if you think about this, this is for our computed object types. And, or excuse me, computed expression type. So this is the result of some sort of computation. So a computed expression is the base type. We've already got computed expression integer. And trust me, as we go along, there's going to be a computed expression float, a computed expression bool, and a lot of others. Because, for example, a function would be a computed expression type. What else? I mean, just dealing with slices and all of those things. There's going to be a lot of different computed expressions. So we want an object pool for each one of those because the amount of memory it needs to allocate for computed expression null is different than computed expression integer. So this needs to be for each, templated for each kind. So template, no, we need that there. So class, and just use T, and then do I need anything else? I think I can go from this point, yes. And so we've got the open, close, and I'm going to go ahead and put that semicolon there because I forget every single time. And first of all, I'm going to mark as private the constructor. Why? And by the way, since this is a template, everything's got to be in the header. So we won't be making a .cpp file. Is that right? Yes. Just like Vector is a templated class. And I'm double checking some notes. Yeah. Also double checking my preview window. Okay. But let's look and see what's public. So public, I'm going to have a static method that is called getInstance. Yes. And it is, so there's two different ways we could do this as a Singleton class. And that is we could either create a private static member down here, but then we wouldn't be able to call the constructor unless we expose it. We don't want to expose it. So the next best thing would be to, in a static method, a static getInstance, this will be a Singleton object pool ampersand. Does that make sense? To have a static member called, oh wait, Singleton object pool of type T. There we go. Pool of type T, and we'll call this pool that is instantiated and return pool. That should work. This is not return get the, excuse me, the All right. That should just work. Now, we're going to need to track several things. We're going to have to do all of our own memory allocation in this, which means we will need a destructor. And anytime we have a destructor, we need the entire rule of 5. Let me hold off on writing the destructor. You know, in one sense, if what would happen if I did not have a destructor? This is a singleton object. If I never call get instance, the singleton will never be created, first of all. But second, it can never go out of scope because it exists as a static variable. So when will it go out of scope? When the program is ended. Okay. Well, if it doesn't go out of scope until the program ends, then that means everything is going to live for the life of the program execution. Now the problem is well, okay, what I was going to say is if it goes away at the end of the program execution, then yeah, goes away at the end. I stopped to double check what I was saying before I said it. If it lasts until the end of program execution and I can't explicitly call the destructor, or you shouldn't do it anyway, but then that means when the program is over, all the memory is going to be freed anyway. The only problem is in any memory profiling thing, whatever, it's going to complain probably about leaking, even though we're tracking all the memory. So I'm probably still going to write the destructor. I don't think that I want there to be an assignment operator. Or a move operator. Does that mean I want to get rid of probably the copy constructor? Yes, you don't want two versions of it. So you don't want to use the copy constructor. I'll think about that. I'll think about all the rule of 5s. But okay, let's just go on. We know that we're going to need to be able to request for an object T. Okay, that's fine. And it's going to return initialized memory location for an object T. Okay, and this is going to be So a T pointer, and this will, I'm just going to call it get. And it's going to do some magic in a little bit. I'm also going to have a recycle. And it's going to have a parameter, and that is obj. And that will be and it's not going to have a return, so it's a void recycle t star obj. We haven't written it yet. Is that all that we need? The get, the recycle, and then the destructor and the rest of the rule of 5? Maybe. That might work. Okay. So the destructor, and that's just a tilde. Singleton object pool, and we're not doing anything yet. This is unaccessible. Or let's just say hidden. Okay. Thinking I like that so far. Okay, so now what do we need to be able to do? Well, first of all, there's going to have to be some sort of max size. And I'm going to, for the moment, do this as a pound define. You know what? I'm going to call this grow. And I'll use a nice number. Clean up after ourselves. And what will this be? This will be the threshold. Okay, that may not make any sense to anyone else, but it makes sense to me. So what does this mean? This means that, okay, so we're going to have private, yes, and we're going to have Um, uh, pointer to this is, no, we'll just call it a C array of allocated blocks. Okay. And I'm going to call this and then C array of recycled objects. Okay, and that's going to be and we'll just call it recycled. Open available. T star. What is this going to be called? What current index? Okay, so I've already given that away. I'm going to call, and this is going to be an int, because when we start out, if we haven't allocated anything, it's going to be a -1. So this is the current index. All right, and now let's do our I don't know if I wanted to do ref. And this is recycled size. And I need to know which one in my recycled array I'm kind of at. So index into the recycled array of the first open slot. There's going to be equals needs to grow. There we go. And this is going to be size t, which is an unsigned integer. This needs to be recycled open. Yeah, and then lastly, we're going to need a mutex. For thread safe. For thread safety. There we go. And this will be mutex and we'll just call it a lock. That means we need a mutex. And you know what? I think I want to make my do I want to make my test program include this? That just includes Tang. What is this called? Computed. Expression integer. And I'll just call that S. Auto I is equal to S, no. s.get. Now, I think I can do this as new three. Well, no, let's make it a different number, 42. And then cout I dump. Okay, should put out that. Can I? So I'm not going to like something. I'm missing an N. All right. So it's, well, $55. All right, here we are back, and I changed my shirt. Why? Because this is the next day. Let's see what happened. I spent an hour and a half or so that I cut out of the video trying to find the bug, trying to find why it wouldn't work. And yeah, the reason it was the compiler, specifically turning on C++20 triggered it. Why? Because they changed something in the language, and I found it here. In short, somebody, I had to go to, because when I realized that it only showed up when I was compiling with the C++20 flag. If I turned it down to C++17, it would not error out. It wouldn't give me the compile error. Only when I went up to 20, so I was like, okay, this has got to be a bug. As it turns out, they changed one of the specifications in the language, and that's what this is. So, and they had a different, before something, but they had a very similar situation, in which case they had a constructor where the template was listed in it. And by the way, this, like I said, it works. And one of the things is somebody says, this is right there. And you can read through, and it's where they changed the requirement. It was not a problem in earlier, although C++17 didn't report it as a problem, but 20 now does. And this bug report is actually still open so that they can improve the diagnostic, but obviously other people have reported this as well. And so that's what it was. Okay. Having said all of that, I have hopefully spared you the problem and or the pain of sitting through all of that. And now I don't know, because I'm not going to record all the earlier parts of it. So I don't know what you've seen and what you haven't seen. So let's just go back to the code. And so what do we have? First of all, the problem was right here. It did not like the fact that I included the template type in the constructor. Which, like I said before, as I understood, you're always supposed to do it. And removing that made it compile. Okay, so now let's go back up. What do we have? We've got the Singleton object pool. Object pool here. Get instance. Do I like that? Yeah, I'll leave it get instance. And then we've got our get that will return something from the pool that we have not created this yet. We're just returning a null pointer so that something will compile. And recycle, we don't have any of that functionality yet. And then private, our constructor is private. Now there's other things like I probably want to remove, we're going to have to deal with the destructor. And in fact, this should, if I remove this, it still compiles. Forget the fact that it has a runtime error. The reason it has a runtime error is because I'm returning a null pointer, and it can pick up on that fact. That I'm returning a null pointer, and then I'm trying to dereference it in the other file. So, okay. And let's see. All of the rest of the stuff is just fine. The other thing that I think I realize is that this mutex declaration needs to happen outside of the class, but inside of the namespace declaration. So there we go. And now let's go to the file. So this is just to test our pool, and that is we want a Singleton object pool of computed expression integer, get instance, and so the pool is what's supposed to give us memory addresses. And now I'm calling new, but I'm passing it in a memory address to say, I'm saying, I don't want you to actually allocate it. I want you to do the initialization here at this memory address. And I'm asking the pool for that location. And it will give me and what am I constructing? A computed expression integer, 42, and then I'm dumping it. Of course, because my get only returns a null pointer, the compiler can pick up on that. And as you see over here, I'm getting an hello? Not sure why it's not oh, there we go. There. You can see I'm getting a runtime error. The constructor call on a null pointer of type struct computed expression integer. It knows that I'm returning just a null here, and it's saying you can't do that. It's a runtime error. Okay, great, fine. That just means that, hey, we get to fix this now. And I learned something very painful. It took me a little while, but I will never forget that. Okay, so I'm going to double check my my kind of helper reference code that I already wrote. But okay, so what's supposed to happen when we call get? That's what we're looking for. And yes, right now it just returns a null pointer. We do not want to do that. First of all, we want to say yeah. If there is a recycled object available, return it first. Okay. Then we'll say there wasn't a recycled object available. And in case you're wondering, I do this a lot when I write code. Just write out the comments of, you know, your flow of thought, and then just write the code to match your comments. So there wasn't a recycled object available. I don't want to say check to see if there is an allocation pool. Okay, then what? If there's not, so there's not any allocation pull memory available. So we need to allocate, I'll put that on the next line, more. And while I'm doing this, I'm going to check the length of this. 79. Okay, we're good. We need to allocate more. And then what? I don't want to say it like that. I'd rather say wire up all the pointers. Sure, why not? Okay, it's gonna just do this until I put actual code in there. So what do we need to do? First of all, we need our mutex, our lock, locked and unlocked. So we're going to say and the very last thing that we'll do is we'll say yes. Okay. I'm not going to do this in the same way, so I will, here, we'll say. So if, is there a recycled object available? What did I call that? I've got recycled. Size recycled open. Okay. So if this we need a temporary that is this arrow recycled and offset by Does that make sense? Okay, so what this is saying is go to this recycled, whatever that is. So first of all, I'm saying recycled open is supposed to point to the first open place. So in our recycled memory area. If recycled open, so if it's a truthy value, well, the first recycled place, I mean, I'm going to say if it's 0, that means as if one is, if something is put in space 0, then space 1 needs to be available. Then space 2, then space 3, then space 4, and so on. So, yeah. So recycled open, if it's a 1, then that means there is some recycled stuff there. But if it's a 0, that means there is no recycled stuff available. Okay, so if there's a recycled 1 available, then my temp that I'm going to be returning in just a moment is going to be the recycled ones and with an offset of this recycled open minus minus. Why? Because recycled open is, again, the first open one. It's the one that's available. And so, for example, if I've only got one in there, memory location 0 or index 0 is the one I want to return, but recycled open will say 1 because that's the first one that's available. So I'm doing a pre-decrement. So it's going to take recycled open down to 1, from 1 down to 0, and it's going to give me the memory address of 0. What if it's, if I've got 15 or 0 through 14, recycled open is going to be 15. So a pre-decrement is going to drop that down to 14, and I'm going to be, temp is going to be what is currently at 14. So that hits all the spaces there. Then I need to unlock my mutex and then just return temp. Yeah. That seems right. Okay, so now there wasn't a recycled object available if we're at this point. Check to see if there is an allocation pool memory address available. So, and what was this called? Current index, that's right. Current index, and I want to, the way I'm going to do this is I'm going to say, is it less than grow? What does that mean? So first of all, current index is kind of like whatever memory pool I'm pointing to. If it's at 0, that means 0 is the one that's available. Now my grow is a number like 1024. That's how many I'm going to grow by. 1024 objects, or maybe I'd take it down to 15. I don't know. We can experiment with that. But right now, 1024. So if it's at 0, that's obviously less than grow. Then that means I've got one available. If it's at 1023, it's still less than grow, 1024. But if my current index, the first one so current index points to the one that is available for me to give away. If it's equal to grow, then that means I'm kind of one past what I have allocated. So I'm doing the correct check. I'm saying, is it less than grow? And if it is, then what? Let's just say there is at current index. Okay, that's fine. Let's see. So allocate, is it allocation or allocations? Allocations, plural. That's right, because my way of doing this is I'm going to have one block, and then later I can allocate another block and allocate another block, but I don't want those to move. So I have an array of blocks. So allocation is an array that's pointed to by this arrow, current allocation. Yes. This arrow, current index. Plus plus. Is that right? Okay, so allocation is like my T star star, my array. My array of pointers to the T. So the current allocation is kind of like can I say the word page, which block we're talking about? And then this arrow, current index, is the one that's available. So temp is going to be equal to that one, and then I'm doing a post increment on that. So current index is going to be increased by 1. Okay, that seems right. And then this lock.unlock. Why? Because now we're going to return temp. That seems right. Okay, This, there's not any more memory available. So we need to allocate more. That's fine. We can do that. So auto, let's just say new block is a malloc of the size of t times grow. Now malloc returns a void star, so I need to cast this to a t star. That seems right. And now we need to say, does it actually exist? So if new block, because if it couldn't allocate it, it'll be null. So if it does, if it doesn't exist, then I just need to allocation failed. And I'm going to borrow one of theirs. Throw bad alloc. Throw a bad allocation. Okay. So now at this point, new block has succeeded, but now we have to resize our current allocation. That's this one up here. The current allocation. No. This arrow allocation. That's it. So is equal to, and this I already know I've got to cast it because it's going to be a realloc, and it's a t star star of realloc allocation that's singular and size of how big, so size of a t star times this arrow current allocation plus 2. Is that right? I've got to think about that, make sure. I'm pretty sure it is. Why is it plus 2? First of all, what is current allocation? It defaults to right there to -1, right? It defaults to -1. So when I'm creating the first one, I need to add 2, so it will be a value of 1. Yes. When I create, let's say I've got 1, current allocation is going to point to 0 because it's going to be, well, offset 0. It's the 0th block, 0-based counting. But now I need it to be the size to hold 2 of them, so it's 0 plus 2. So yes, we're correct there. All right, now, because we did a realloc, we have to make sure that the realloc succeeded, right? So if not new allocation, let me say the realloc failed. Clean up and keep wanting to say raise. That's from a different language. So what I need to do, first of all, I'm just going to get out of here or unlock because that's fine. And now I need to free new block because I allocated it up here and that allocation succeeded. And then I need to throw a bad alloc. The malloc failed. The realloc failed. Clean up. Okay. Oh, hey, we're almost done. So the allocation succeeded. So what do we do here? Let's see. We're going to... is equal to new allocation. There we go. I don't think that, yeah, in fact, I know for sure that realloc does not... yeah, because it just takes a pointer. It does not take it as a reference. So it's not going to change allocation if it succeeds. Okay. So then I need current allocation to increase by 1. So my habit is to use the pre-increment operator because, well, G++ is probably sophisticated enough that if you put a post increment here and that's the only thing there, it would treat it as a pre-increment. But I do this because sometimes you use a language whose compiler you're not too sure about how sophisticated it is. So pre-increment, okay. Excuse me. This allocation is equal to the new block. Yeah. Current index is going to equal 1. And you may say, Corey, I thought you said current index is kind of like the first one that's available, so shouldn't it be 0? I would say, yes, but we're about to return the 0th one. So we can unlock... No. I was about to make a mistake. If I say this allocation, this current allocation, 0, is that right? I do know I need to return temp, but you know what? Let's just see if this is... T star. And you know what? We don't need autos. Do I have autos in other places? So allocation, again, it's a pointer to a pointer to T. That's right. So if I say this, that's resolves to a pointer, but sub-0 will be the, what's funny is I could just do this. Now, it's still saying getting a segmentation fault. Constructor called a null. So why is it a null? That's a very good question. So at this point, our get should be wired up. Control or command B2. 31. So here's what we're going to do. We're going to okay, finally. Oh, okay, so it's not liking the bad Alec. Why? Why? What did am I missing something? Am I missing a header? Just out of curiosity, is it okay, so that fixed that. It needed standard. Now, 65. Evidently, I don't know how this language works. I don't think I even need the parentheses, but that's my habit. $75. Of course. Forgot the semicolon. $48, it's allocation. Oh, it is allocations, and I've been writing allocation. Yeah, I'll do allocations. I think that's better. All right, now what's it not liking? Cannot convert computed expression integer to a pointer. So line 48. Oh, of course. I need the ampersand there. And 74, I missed one. And notice the memory address is changing. There we go. DB0, DC0, DD0, DE0. So, you know what? So that seems really big, but maybe it's... Oh, 16 bytes? Which is... Yeah, 1 0 in hex, so it's incrementing that. It's working. Okay. And now if I... Will my... this work? It does print out a 42. Yay! Now, here's the interesting thing. If... And now I'm just kind of playing around, but the question is if I recycle something, what do I get? So, we need to do the recycle, right? What's this going to look like? So, in recycle, we've got recycled, which is a null pointer, and I'm, in case you're wondering, I'm looking down here. Recycled is a null pointer, and then the recycled size is, that's going to be, yeah. The recycled size is, you know, how big this recycled area is, and then recycled open is going to be, you know, what's the first empty spot. But that means we're doing more allocations here, and so the first thing we need to do is say this lock dot lock. Okay, and now in the current recycled block. And I could do this the same as the allocations, where I'm doing just one small block that and another one. I'm not convinced I want to do that yet, but we'll see. So recycled open is the first available one, and if it is equal to recycled, no, this. I know I don't have to put this, okay? Personally, I think it's cleaner. Then you don't have to say m underscore everything, which to me is messy. I know it stands for member, but it, yeah. So what is recycled is a T star. Okay. So T star And then the size of T star times this recycled size plus grow. We're just going to use that again. Notice we're not actually verifying that this is one of ours. Unlock it and throw a bad Alec. Sure. Now, if it didn't, then and that means we're wiring that up and okay. And it's going to be this recycled open is equal to P, that no obj, that's what I called it. Object, and then I need to increment recycled open so that points to the next one, so we can just do that as a post increment. Yeah. Okay, now what's our destructor going to look like? We're not calling destructors. That should be up to whoever's using our pool. So we're going to current allocation, and this should be less than or equal to, is that right? Yes, because current allocation, when it's -1, that means we haven't allocated anything. Okay, yes, this is all correct. So what do, there we go. It's O, not Shift O, to get a line underneath. Let's see. We're going to free allocation sub I. And then free recycled. That could work. In fact, yeah, that makes sense. We're cleaning up all the allocations that we made, and we're freeing recycled. Okay. Now, if we go back here, there's some things I want to try. So I is using the pull get and I dump. Okay, that's fine. Now I want to say auto j is equal to new pull dot get integer -8. Sure, why not? And then okay. And now I think I want to do the pool dot recycle the memory location of I. And now K I don't want to do 0. 2024, sure, why not? And what we're doing. Just putting a line of separation. All right, so what are we expecting to see here? Oh, of course, these are pointers, so I don't recycle ampersand I. But that's okay. It lets me explain what I'm hoping to see, what I'm planning on seeing. So we're going to get that. We already know the size of computed expression integer is 16. So we're going to get this. We're going to get the I. And it's going to have a value of 42. Then we're going to get j, and it should be 16 bytes after that. I'm recycling I and getting k. Now the way I wrote this is I said look at the recycled first and use that. So k should actually be i's memory location, but with the value of 1024. That's the goal. Let's hit save. It's not liking something. I, J, and K are pointers. They're not the actual objects. Is that... It makes sense then that they... It works! Again, why people hate pointers, and it doesn't bother me. It's more of I'm just out of practice with them. So what was the problem? I was saying, give me the memory address of I, give me the memory address of J, and give me the memory address of K. But I, J, and K are already pointers. And so this is the memory address of a pointer, and the memory address of a pointer, and the memory address of a pointer, because they're all three different places. Their I is bound to one place in memory, J is bound to another place in memory, K is bound to another place in memory, and they're not the size of a computed expression integer. They're just the size of a pointer, which is, as we saw, evidently 8 bytes. So, but if I say cout I itself, that is the memory location that I is pointing to. And we can see here that it is, come on. There we go. B0, and then when it gets recycled, and then I ask for another one, it gives me B0 again, but its value is 1024. So it did the initialization. So it's working. Yay, I'm happy. And we can see that again, by the way. B0, C0, D0, E0, F0, and then it rolls over. So that worked as expected. Whew. So what does this give us? This gives us a singleton object pool. Now, we should probably write some things so that it cannot be copied. Right? You don't want it copied. Moved, I don't mind it being moved, but I don't want the copy constructor. And in fact, we can do that right now. We can do B1 and what does the copy constructor look like? It pool that takes a const. Oh no, I'm hoping this is right. No, I'll just leave it there. We'll see if it no, I'm gonna ampersand other. There we go. Does not like it. It makes sense to me that it should be there. Const. There we go. Okay. That hides the copy constructor. Why? Because you don't want, if you've got a singleton, you don't want it to be able to be copied. I left the move because my idea is if you're moving it, you're just moving everything along with it. It's not, you're not going to have more than one version of it. So the move should be okay as is. But, okay. Yeah. So I think that's right. Having said all of that, so we've got some interesting stuff here. We're not writing proper tests yet, but we will pretty quickly. Why am I doing Control Q? There we go. Get status. Actually, get diff. So in our make file, we added that as a dependency. Yeah. Ooh, we have some white space. I don't like that. Let's fix that. So Vim, this is in our test. Yeah, you got that. There we go. Now if I rerun that, see there's no extra white space. Git add the make file, test, and our Singleton object pool. And this is going to be and now it's HTML index. There we go. And we should have in our files, under includes, we'll have our Singleton object pool. Yep. Gotta grow, and it has this class. Notice it's hiding the private stuff. Good. And yeah, I think that's all we need to do for right now. And that would update the PDF. And now where does that give us? That is a... It's only changes in docs, right? Yeah. Oh no, which episode is this? I had to look at it. Episode 8. Okay, git push origin master, git tag -a. I'll need that. Episode.008 -m is also episode.008. Git push origin episode 008. And it's live. All right. So thank you. I should bookmark that link. But anyway, okay, if you made it this far, thank you. I know that there were a couple moments in there where it just took a while. And part of it is my own issues with pointers. And like I said, I'm not complaining about pointers. I actually really like them. I think they're cool. I think they're fun to work with. But seeing as how I'm not using kind of like a full-fledged IDE, you have to think through everything. And you might think that that's a problem in the long run. But for me personally, I prefer it this way because I understand it a lot better, and I'm constantly aware of those issues, of all of the ins and outs of using pointers. So, yeah, I would do this any day of the week. Having said that, okay, we got through it. And the next one we're going to be looking at I've got to decide. We're either going to do testing, start doing testing for this, for that class that we just built, or we're going to build our reference counting class to keep track of our big picture. We need a reference counting class that can hold our our computed expressions. Once we get that, then we can refactor our program execution so that it uses the reference counting, and it uses that in the stack. And then we can start building more stuff. But we also need to start making sure that our testing is in place, because I've written a lot of code here without writing tests, and I don't like that. So if I say make clock, how many are we up to? Of C++, it's only 246. Well, in the header is 241. So add that together, you get almost 500 lines, or total almost 700 lines. Yeah, I prefer having tests by now. I should have a while back, but I was trying to at least get more of the structure of this programming language in place. Oh well, we're going to do that. We're going to make sure that our unit tests are written in a comprehensive way, and in a way that keeps us out of trouble as we go about what am I trying to say? Yeah, as we go about further development, right? So that's the goal. Okay, having said all that, again, thank you for being patient with me. Now I've got to edit this down so it's not as painstaking for you to watch. And yeah, I'll see you next time. Have a great day.